In the previous video, I explained some of questions of this example. In this video, I am going to explain the rest of the questions. First one, find the 80th percentile of the distribution of orange weight. This problem asks you to find x value from a probability. Find the x value that has 80% of the area from the left corner. The x value on the x-axis is named as P80. Then we need to find the P80. What is the first step to find the P80? Here the area left of P80 is 80%. That means 0.8000. Since we have the area left of P80, we can go to the table and find the value 0.8000. We know we cannot find the exact value, but 0.800 must be in between these two numbers. Then we need to check which one is the closest one. That is the 0.7995 and find the corresponding z value to this number. That is 0.84. Therefore, we have the z value from the table for the P80. Now we find the z value for P80 using the formula x minus mu over sigma. Here x is P80 and mu and sigma are given, so z value is this. Now there are two z values, one from the table, other one from the formula. So these two must be the same. So make them equal each other and solve for P80. So that is the 80th percentile of this distribution, that is 9.26. Now go to the next. Find the 5th percentile of the distribution of orange weight. Yes, it is similar to the previous one, but here we consider the 5th percentile. Again, this problem asks you to find x value from a probability. So find the x value that has 5% of the area from the left corner. We always consider the area from the left corner to find the percentile. The value on the x-axis is named as P5. Therefore, we need to find the P5. What is the first step? Yes, area of the left from the left corner is 0.0500 because it is 5%. Now directly go to the table, find the 0.0500. We know 0.05 is exact middle number of these two numbers. Therefore, we need to consider the two z values and find the average of these two z values. Therefore, our z value of P5 from the table is negative 1.645. Now we need to find the z value using the formula x minus mu over sigma. X is P5, so z value is this. Now there are two z values, one is from the table and other one is from the formula. So we can make them equal each other and solve for P5. So that is the 5th percentile of this distribution, that is 5.53. Find the interquartile range of the distribution of orange weight. First we need to know what the interquartile range is. IQR, Q3 minus Q1. We know the area under the curve and between Q1 and Q3 is 50%. So first find the Q3. How do we find the Q3? Again, to find the Q3, we need to consider the area under the curve and from the left corner. Here we know that should be 75%. So value on the x-axis is Q3. So we need to find the Q3. What is the first step? Again, the area left of Q3 is 75%, which is 0.7500. Since we have the area left of Q3 or area from the left corner, we can directly go to table, look for the number 0.7500. We know 0.7500 must be in between these two numbers. Which one is the closest one? Find the corresponding z value. So that is the z value from the table. Now use the formula x minus mu over sigma. Here x is Q3. Then find the z value of Q3 using the formula. Now we have two z values for Q3, one from the table, one from the formula. Now we can make them equal and solve for Q3. So that is the Q3 value for this distribution, which is 9.005. Now we need to find the Q1. Again, how do we find the Q1? Consider the area from the left, and that area must be 25%. Right. The value on the x-axis is Q1. We need to find the Q1. First step. The area left of Q1 is 25%. So we can directly go to table, find for the number 0.2500. We know 0.2500 must be between these two numbers. Select the closest one. Then find the corresponding z value. That is negative 0.67. That is the z value for Q1 from the table. Now use the formula. Here x is Q1. So z value from the formula is Q1 minus 8 over 1.5. We know there are two z values for Q1. One from the table, other one from the formula. Make them equal each other. Solve for Q1. Q1 is 6.995. So now we know Q1 and Q3. Now we can use this formula to find the Q1 and Q3. As I explained before, the area between 6.995 and 9.005 is 50%. Since we know Q1 and Q3, we can find the IQR, that is 2.5.